This is Physics Paper 1, 5054, O-Levels. The grade threshold out of 40 is mentioned here. Let's start with the first question. Which list contains only vectors? So mass is not a vector, so we're ignoring this option. B, momentum is a vector, it's directional, gravitational field strength. G is also a vector because Newton per kg is right. Displacement is also a vector. Energy, no, it's not a vector. Acceleration, vector. Time is not a vector, so no, the best option will be option B. Question number 2, he said diagram shows distance time graph. So a distance time graph, let's write down what the gradient represents. It represents the speed. Whatever this is, the gradient was very high at the beginning, so the speed was high. Eventually, the gradient became 0, so the speed should become 0. So we're looking at a motion that is supposed to stop moving after a certain time. A cricket ball thrown upwards vertically and falling back to the throw. In both movements, the ball is moving, so it's not possible. The car starting from rest looks fine, speeding up, that looks fine, moves away from it. Now, this is not possible because the speed is not 0. As still moving away, speed is not 0, but we want speed to be 0. Part C, rock dropped from a high cliff falling into the deep sea below. Now, even if it falls into the sea, the ball will not, or the object will not stop moving, it's still moving. Either with a lower gradient, with a lower speed, but still moving. So this can't be the option. A train braking to a halt, yes, this. So we need something in terms of the idea that it's going to stop moving. It's going to stop in its tracks with speed being 0. So D looks like a good option. Question 3 has been a repeated question from the past papers. He says object falls with the terminal velocity. It's a speed time graph. So the gradient represents acceleration. Now we're looking for terminal velocity. The acceleration is supposed to be 0. Now in A, the graph is steep. C, the graph is steep. The acceleration is not 0. The gradient is not 0. B or D could have been the answer. Now notice that even in B, the gradient, the line hasn't come completely flat. But in D, it has. So the gradient is 0, hence the speed is not 0, but anyways, the acceleration is 0, which means it's moving at terminal velocity. D should be the answer. Question 4. It's a nice question for the sake of practice and visualization. Constant speed, and you've read the question clearly. It says students suggest area x and y represent. Area x represents the thinking distance. This is a true statement. Why? Because at the moment a person sees the danger, you lift off from the throttle pedal and start moving towards the brake pedal. And during that time, the short amount of time, the speed of the object or the car remains constant. This is its indicator. That is going to be the thinking distance. And when we say thinking distance, this will be, of course, the area under the graph calculated, because distance for speed time graph is represented by area. Area y represents the stopping distance. Now, the stopping distance actually has the thinking distance plus the braking distance. Now this is the braking distance, right? Okay. Now it says area x and y, and now this statement is true. It says which students are correct. This is student 1 and 3. Okay, both areas have to be added for the stopping distance. Stopping distance, this is not stopping distance, this is actually braking distance. Anyways, question 5, he says limit of proportionality. That's very, very simple. Before the curve, any point before the curve, that's going to be option A, because beyond this, the line starts bending and it goes through B, C, and D. The A option will be the limit of proportionality. Question 6 suggests that there is no atmosphere on the moon. When you talk about identical volumes, they are generally talking about, or in terms we can think that they're talking about the same surface area exposed. We should have been worried about this, but only when the atmosphere was present. But the atmosphere is not present, which means that we don't need to worry about this. He says how the spheres move after they are dropped. One of them is probably different masses. Yeah, one of them might be heavier, one of them might be less massive. So the idea is that they will hit the ground together because the atmosphere is missing. The same thing will happen on Earth. If you throw two objects of different masses, for example, a brick or a feather, in the absence of air, they will fall together at the same time. The reason they fall differently on Earth is because we have atmosphere, we have surface areas, we have drags. They are different for different objects based on their shapes. Question 7 has proven to be a bit tricky. but we'll try to solve this. It says we want to find the density, so let's write down the formula for density. That is going to be mass divided by volume. Now, change in volume is very obvious because going from 100 from 147. Previously, the volume was 100. Today, the volume is 147 after placing the rock in it. So the change in volume is 47. But since we're working with centimeter cube, the centimeter cube stays. Now, the weight is 1.2, and we're doing this on Earth. So for mass, we're going to use the formula W equals mg. I want the mass. So this will be simply W divided by g. So this is 1.2 divided by 9.8. Now notice that the value of g is basically 9.8 newtons per kg. So if I get the answer of this, this is going to be kgs. And yes, you find the answer. This is going to come out as 2.6 into 10 raised to the power minus 3 kg per centimeter cube. So if you look at all the options, they have grams in them. Grams. Newton per centimeter cube is not a unit for density. It's supposed to be mass over volume. So the best answer would be to multiply this with 1000 to get it from kg to g to grams, and then it becomes option D. Question 8. It says to find the kinetic energy, very simple, very easy, half mv squared. Mass is given, velocity is given, so 1 over 2 into mass is 20 into 36, or simply 6 squared. This is going to come out as 360 joules of energy. Which describes the advantage, disadvantage of using nuclear fuel. Now, this is a push from the Cambridge examiner this time around, that the students need to be thinking about sustainability and its goals in the future. As young people, as young learners, it's your responsibility to think about how energy is produced and how it's utilized and what impacts it has on the environment and the future. So advantage definitely is that it does not produce carbon dioxide, but it does produce radioactive waste. So option A will be the best answer for this question. Question number 10, he says, which definition of work done? This is simply force into distance, but the condition is that the force and distance covered should be in the same direction. Once that's done, the unit is joule. So we know there's going to be either A or C. But let's see, energy transfer per unit time. Now, energy, joules per time or second, is basically power. So we are wrong about the definition, and we're wrong about the unit in terms of power as well. So let's check option C. The force multiplied by distance. This is the right answer for work done. The option C will be the correct answer for this. Question number 11. He says a hammer is hit. Now this has been a repeated question, not exactly in this setting, but also in P2, that the force generally comes out to be the same. And this is according to Newton's third law. If you, for example, moving the hammer applies a certain force, let's say F hammer, then the opposing force by the nail, Fn, will also be equal to this according to Newton's third law. Action, reaction, equal but opposite. But the problem is that what is the difference in pressures? You see, applying the same force, because pressure is equal to force over area, the forces are definitely equal. No one is greater than the other one according to the third law, but there is a difference of pressure. Now let's see what the pressure of and pressure PW on the wood. This is on the wood. That's definitely going to be greater than what the pressure is going to be on the nail head or on the hammer, or exerted on the hammer, purely because of the surface area in contact. This area in contact of the nail with the floor or with the wooden panel is less, so pressure will be higher when the pressure was constant, when the force was constant. So the best answer is this, going to be this one, pressure wood greater than that. Best answer is option A. Let's move on. Question 12. He says pressure XYZ for liquid. Okay, liquid. So liquid pressure is rho GH. He says which changes both increase the gravitational pressure, increase the pressure, change in depth. Yes, it does, but increasing the depth increases pressure. And then the next statement is the surface. Change in density, yes. So if you increase the density, pressure of liquid increases as well. So both quantities, when increased, change the liquid pressure. Question number 13. This has proven to be again a confusing question for students. I get this question a lot. It's not that difficult. It's not that big of a deal. You see, the piston is free to move, which means that there are no friction elements in this. And atmospheric pressure means that on the outside, the piston is exposed to the atmospheric pressure. As the air inside the cylinder is heated, when you now notice that the temperature is directly proportional to the kinetic energy of molecules. which is directly proportional to the speed of molecules. Now, if you increase the speed because of temperature, now force is actually change in momentum divided by change in time. If you increase the speed, the mv factor increases. When the change in momentum increases, the applied force also increases. The question is about the quantity decreasing. The option A is the average force. No, the average force will increase, not decrease. And that's how the whole system is going to go. So you see the pressure inside the container increases very slightly, partially. Only then the slider moves outwards. And then we start observing P inversely proportional to volume. The moment pressure, for example, increases, it pushes back to this area, the volume increases. At the moment volume increases, the pressure goes back down again. And that's exactly what is happening here. But anyway, that's a theory for another day. And it happens in very small increments, very, very tiny increments. The moment pressure becomes, for example, the outside pressure is 1 atm, the inside pressure because of thermal energy becomes 1.1. The inside pressure is greater than the outside, the plunger moves this way, and the internal pressure becomes 1.0 again. Because we're continuously providing the thermal energy, it becomes 1.1 again. The internal pressure increases, the plunger moves out again. So it happens in very tiny increments if you go about that. So option A is not possible. Average speed of the air particles, no, it is increasing, as I've earlier said. The mass of, now this is again a common answer, a common point. The mass of air cannot change because the mass is the number of atoms, is the substance inside the cylinder. If there were a billion atoms inside the cylinder, there are still today billion atoms inside the cylinder. We haven't changed them. So this is not the answer. The number of collisions made by the air molecule per unit, yes, they do decrease because, as I said, that when the volume increases, the space between the current position and the old position, for example, like this one, you provide more space, the collisions that they were having initially with the boundaries, well, whatever number that was, if you apply or provide more space, they have longer time to fall. They have longer time to move through the cylinder before they encounter a collision, which is why option D seems to be the right answer. Question 14, he says, fixed volume, fixed pressure, that's fine. Volume changed to 2. Now be advised that sometimes the examiner uses the word by. Volume changes by this much. So when it's by, it's going to get added into the equation with the previous one. If it is changed to, that means this is purely a new situation. So since we're dealing with the air, which is gas or gas pressure, that will be P1 V1 equals to P2 V2. Initial pressure is 120. I'm not ignoring the kilopascals because my answer also have kilopascals, and it will eventually come out in the right way together. Then we have 150 volume equals new pressure, which is to be found, and new volume, which is 100. When you solve this problem, your final answer is going to come out as 180. Let's move on to the next question. 15. Now notice what they've done in 15. Usually what they do is that instead of gas, this is usually solid, and this is usually gas. And that's how we teach this topic in the classrooms. So be careful about this. The examiner started swapping places to confuse you even more. And it's a very easy question. It's not that big of a deal. It's not a problematic position. We just want to be familiar with these numbers and changes of states. Question 16. How metal plate transfers energy to the pan. And this is very obvious because they are in contact with each other. Solid object to solid object is conduction. Convection will go on into the liquid, but only when the liquid absorbs energy from the base of its own metal pan, not before that. A beaker of cold water is heated at its base, fine. What happens to the heated water? Density of the heated water, it decreases because this is going towards convection current. That's what's happening here. So hot air or hot liquid rises up, gets replaced by colder water from other parts of the liquid or air. So movement of heated is going to be upwards. It's going to be option B. Let's move to the next question. Question number 18. He says, now this question is about memory, what you know about longitudinal waves. So variation along the sound wave, which points to rarefaction and the wavelength. So wavelength is very easy to see and very easy to figure out. It's basically the gap between two high pressure zones or two low pressure zones. So it's going to be X. very simple. Now, if you look at pressure, this pressure is high and this pressure is low, but this is atmospheric pressure or mean pressure. P seems to be the compression phase of sound when the pressure is slightly higher, particles are close together. And Q seems to be the rarefaction phase when pressure is low. So the best answer to this will be Q and X. This is option C. Question 19, he says a cork, okay, on the surface, water moves up and down and waves passes across the surface. The diagram shows how the height of the cork above the average level surface varies. Okay, fine, we understand the question. And now we want to find the speed of the wave. Now, since it's the wave speed, we're going to use the formula V equals to F lambda. Now, notice that this is time period, and from time, we can find the frequency using this formula. And please be advised that since frequency is 1 over t, by rearranging this formula, this is time for one wave. This is 1 divided by that number. Don't take the total time. That is the mistake. I don't understand why we are always taking the total time. No, it's wrong. We take the time for one wave. And for one complete wave, there is a crest region, there is a trough region. This is the time for one complete wave, which is going to be 1 divided by 0.5. If you want to go beyond this point, then please count the number of waves. If you want to go up to this point, then you've covered 2 waves. So your answer will be 2 divided by 1. If you want to go even further than that, you're considering, let's say, 3 waves, then it will be 3 waves divided by 1.5. So if we say 1 divided by t, that we are considering 1 wave time divided by its own time. That's going to become frequency. Now, frequency is very straightforward, but lambda is a problem. He says the numerical value of the wavelength, lambda, is equal to the numerical value of the amplitude. Now, this is another test by the examiner. Can you figure out what the amplitude is? Will you pick 4 or will you pick a single side? So amplitude is just the single side, maximum displacement, which is 2. So equals 1 divided by 0.5 multiplied by 2, since it's in centimeters. The answer is going to come out of 4.0 centimeters per second, which is option C. Question 20, water wave travels from deep to shallow. This is a refraction case. Frequency does not change. V is proportional to lambda. If you're going from deep to shallow, speed decreases, wavelength decreases. So both options should be decreases. This is option D. It's from memory, it's from knowledge that you've already acquired in this chapter. The diagram shows, okay, fine. First, we need to draw, for the angle of incidence and reflection, we need to define, or we need to first draw the normal. The reason we draw the normal is to take the angles from this reference point. This serves as a reference point because it makes an angle of 90 degrees with the surface, although the surface is from this side. But I'm avoiding writing this down over here because I want to find or label the angles. This will be the angle of incidence because this is the arrow that shows me that the wave is then incoming from this side. And it's going to go away this way. And if this total angle is 90, this is 40, then this will definitely be 90 minus 40, which is going to be 50 degrees. And since we're working with the mirror, the angle of incidence will be equal to the angle of reflection, which means that this angle of reflection should also be 50. It's going to be option D. Question 22 is a repeated question. It gets you many times in the past. First, let's dismantle all the problems which are incorrect entirely. Option B is incorrect because whenever there's a change of medium, there should be some bending, some change of side of the wave. This is wrong on that account. Option A is wrong on the account because when it moves to the air, its speed increases and it starts diverging away from the normal, or its angle increases, right? The angle increases. Now, that's why this is wrong. Option C, again, there is no deviation shown from the change of medium. Even if this is true, there is no deviation shown. So this option C is wrong. So even by elimination, by basic knowledge, we will land on option D. But let's see what's right with D. He says the critical angle is C. And the critical angle, the name of the critical angle suggests that the angle of reflection should be 90 degrees in the other where it goes. Because it's on the verge of trying to come back to the same medium, it failed to exit that medium, which is why we will choose D as the option. Now, you might get confused about these two results. Are they true? Yes, they are. So there's partial reflection or partial total internal reflection at exactly critical angle, and there's some wave still exiting the surface or trying to go into air, but is failing to do so. The moment, for example, this is 41 degrees, the moment you make it 41.1 degrees, this wave will vanish and all of this will transfer into this. If you go, let's say 40.9, then all the wave that is here will vanish and you will get this one. So it's about numbers and how we visualize this. So both waves or light rays will be correct exactly on the critical angle. Question 23 serves to be a bit of a problem. No matter what happens, never leave the rules that I've taught you in ray diagram. So you use a ruler, draw a straight line to the center of the lens, and then pass it from the focal point straight as it is. The second light ray that you're going to draw is going to be from the optical center. It is going to go something like this. Apologies, it's a bit farther away, but it should be going from this point. Now you notice that these light rays are actually going away from each other. They're never going to meet. Then you realize that it's a convex lens. And convex lens, if you place an object between focal point and optical center, start behaving like magnifying glasses. As I've mentioned in my classes, magnifying glass is a repeated case. It's one of the favorite cases by the examiner. So it's better still to memorize it rather than to risk it in the examination. Now these light rays are not meeting. What I'm supposed to do? The common trick would be to extend the light rays backwards, because they are expected to meet somewhere. So let me try this with a dotted line. And we don't know where they're going to meet, so I'm going to continue back as far as it goes. Same thing or same rule for B, the blue line. So again, straight line, straight line, straight line, something like this. Now, if you do this properly with a ruler, you will realize that this is going to come down to 1, 2, 3, over here. The point of intersection will come somewhere along this point. Wherever that point of intersection for blue line and red line is, this is where the image is created. So this is, let's say, 1 box high. This is 1 box, 2 boxes, and 3 boxes. You can count this in terms of centimeters or measurements, but since it is about boxes at the end of the day, we can simplify this for our understanding. The magnification is height of object divided by height of the image. So this is our, for example, this is the image divided by object. This will be HI divided by HO. This is my image, and this is our object. So the image is 3 boxes away. The object is 1 box away, so it's supposed to be 3. The magnification will be 3 times. As I've said, do this properly with a ruler and you will get the right answer. The statement of red and violet is correct. You see, I've also mentioned this, that the wavelength of red light is 700 nanometers, and you're supposed to memorize this because you will find questions like this in the past papers. And if you don't know them, if you don't memorize them, you won't be able to solve these questions. Which statement about red and blue or violet is correct? A prism deviates red light more. This is false. It's the blue or violet that deviates more. If you remember, this is our case. White light coming in, we get red first, and the second light ray we get on the extreme is violet. It bends more. Red light has a lower frequency. Yes, this seems to be the right answer. Red light has a shorter wavelength. No, this is false because we memorize them. The speed of light in the vacuum is less. No, this is completely, utterly wrong because they are all moving at the same speed, which is 3 into 10 raised to power 8 meters per second. This is exactly why we have this V equals to F lambda. If this is V is constant, we have a very simple relationship that frequency is inversely proportional to lambda. So if red has a longer wavelength, then its frequency will be lower. And if we visualize violet has a smaller wavelength but higher frequency. So option B should be right. And this is true because V, speed of light, is constant. Question 25. He says ultrasound is used to clean jewelry. That is fine. What's another use for ultrasound? Optical fiber. That's with infrared communication. Prenatal scanning. Yes, true. That's the answer. Photography. That is for visible light. Telephone communication. That is for radio or microwaves. So this is again wrong. Question 26. It says a spaceship is stationary at the surface. This is a ship, for example. This is the ship. This is water level. This is seabed. So any sound pulse sent down is received back in a time of 1 second. And then there's a whale that's swimming underneath the ship somewhere here. And this sound goes and comes back in a total time of 0.6 seconds. This was 1 second. This is 0.6. Now, ideally, you can use the formula for echo, which is speed equals to 2d divided by t. This is 2d divided by t. But what I would advise you is to be a bit more conceptual. You see, if this is the total time, then divide this by 2. You get one distance or one-sided distance as 0.5 seconds time. Same thing do with this one. You will get 0.3 seconds for one side. Doing that, I'm going to remove all of the arrows and draw them as a single arrow, thinking that they're covering distance in just single direction. So this is definitely 0.5 seconds. This is 0.3 seconds. The question is, what is the distance of the whale above the seabed? So the question is about this part. How high above is this? Okay. So first, let's find out the distances of both sections. So for this one, we have speed equals to distance over time. Speed is 1500. So 1500 multiplied by 0.5 is equal to distance. So distance comes out as 750 meters. This distance is 750 meters. What about this distance, about the whale? So again, same idea. Speed equals to distance over time. 1500 multiplied by 0.3 seconds, time for one side. The distance comes out as 450 meters. So if this is 450, this is 750, and this is very simply a subtraction of both numbers, which is 750 minus 450. This is going to come out as 300 meters. Ultrasound waves, again, apart from memory, this is, since it is sound, is longitudinal. Now, you might confuse this with ultraviolet. Please don't do that, which is why they've given transfers as an option. Okay, frequency, smaller than 20, no, it's greater than 20,000 hertz, and the human audible range is from 20 hertz to 20,000 hertz, which, tricking you, he's written down as kilohertz, so be careful. Question 28. The quantity is defined as work done. Now, I will show this to you in the syllabus. If you notice, this is your syllabus. Notice what's actually happening here. So the first part is EMF. Source is moving a unit charge through the complete circuit. But potential difference is only across a component. So it's already given to you in the examination, the syllabus. So based on that idea, this is, since he's asking me about the complete circuit, it should be EMF, electromotive force, and the unit for electromotive force is volts. Why? Be that for voltage, be that for potential difference, be that for EMF, they all carry the same unit. This is an interesting question in terms of electricity and its practice. Voltmeter readings asked from us. What we can do is simplify the circuit first. So this is in series, these are in parallel, this is also in series to these resistor combinations. So first we need to simplify them. We have developed a trick that if there are similar resistors in parallel, we can just halve the value of one of them. Or if you want to apply the formula properly, this will be 1 by 6 plus 1 by 6 plus, equals to 1 by R. The R after LCM and reciprocal is going to come out as 3 ohms. You can try this. Now, we have combined these two resistors together. For example, we've combined them together to look like today as a single resistor that will have a value of 3 ohms. So in place of them, today we have 3 ohms connected here, like this. Now, since this is now again in series with this one, we can combine them together as a single entity, which is going to look like this. 3 plus 3, which is going to become 6, which is going to become 6 ohms. So over here we have today 6 ohms, battery connected like this. Now notice that this voltmeter is actually connected across 6 ohms. It's not connected across anyone else. We have 6 volts, equal resistors. The voltage will be divided equally. This gets 3 volts and this also gets 3 volts. If you're not convinced, what you can do is apply V equals to IR and see that this is 6 ohms, this is 6 ohms. The combined resistance as a single resistor will come out as 12 ohms. 6 volt battery, the current in the battery will be V equals IR. Voltage available is 6 volt. The current we don't know. Total combined resistance is 12. Current comes out as 0.5 amperes. Since you want to find the voltage of 6 ohms, the current through this is 0.5 amp. So applying V equals to IR on this gives me 0.5 multiplied by 6. as 3 volts. And if you're clever about this, you notice that this is 6, this is 6, voltage gets divided equally, it's a series circuit, so on and so forth. That's how you simplify the circuit. 30 is again from rules from your syllabus. If you notice, this is a series circuit require for potential division or voltage division. The idea comes from V equals to IR. Current in series circuit is constant, so V is proportional to R, which means that the voltage consumed by R1 is going to be proportional to its behavior. So if R1 is greater than R2, then V1 will also be greater than V2. And this is the behavior that is extended from this equation, and the equation becomes V1 divided by V2 equals R1 divided by R2. It's very simple. So if the expression is V1 over V2, the other side should be R1 over R2, and I will show this in your syllabus. Notice that it's over here. It's mentioned in 4.3, 3 over here. And generally, this is referred to as a potential divider circuit, in which voltage or potential divides based on their own resistances. It's a series circuit, effectively. Question number 31, he says the current is given, 4 ohm resistance. He wants to find the energy. Looking at the MCQs, there is 1 minute. So we have power equals energy divided by time. Let's take this over here. So this becomes power multiplied by time equals to E. E equals to power, which can be found by IV. So I multiplied by V multiplied by T. Time has to be in seconds. Current is 1.5. Resistance is 4. So 1.5 multiplied by 4 multiplied by 1 minute into 60 seconds. This is going to come out as 540 joules as option C. Question 32 is a bit tricky, and I'm going to show the slide where I've added notes for them. You see, he says that it's going to be a 180-degree rotation, and let me show you what we mean by that. So if we go to the generator, this is what it looks like. Okay, right now, whatever its position is, if B comes up and C goes down, and then B comes here and C comes here, this is actually 180-degree rotation. It's not a full rotation. A full rotation would mean that if left side has B in it, for example, if this is the starting point is B, then completing a rotation, the B should come back to this position. So 180 degrees only means half a rotation. That's one thing that you need to keep in mind. Half rotation means that you're only going to get half a wave. So let me show you what that may look like. So ignore the positions and everything else, but look at what the half wave looks like. Half wave is actually going to look like this, or even this. This is also fine. But now we need to describe what's the starting point. So first, let's eliminate the options which cannot be possible. If you're looking for half a wave, then I should expect something like this. From full wave, half wave extracted or taken away. So it's going to look something like this. It should. Okay. All right. So A looks to be the fine, looks fine. B also looks fine for the current position. C is wrong because it's showing me a full cycle, which is not possible in 180 degrees rotation. D is impossible. This is completely impossible. The EMF is not decreasing constantly. It is alternating like option C. So we are rejecting C and D based on our previous knowledge, and we have to now decide between A and B because both could be correct. They're both having half a wave characteristic. Now, for this, we need to go back to the syllabus. For example, this one. This is orientation coupled with what the EMF will be based on the orientation of the coil. So right now, if you visualize this, the coil, to your eyes, if you're standing here, looking above like this, looking in front, your A side is here, and your D side is on the right side. This is on the left. You're looking at this as a horizontal plane. Now, when this rotates like this, this is going to get into a vertical plane, like this one. Okay, so that side is visible to you like this on this diagram. So let's notice a couple of things. Whenever it's vertical, whenever the coil is vertical, notice what is the EMF. The EMF is 0. There is no EMF, and there's a reason for that. You see, when the coil is actually in this position, for example, this between these magnets, if it was in this position, there is no change in magnetic field. Why? Because north and south and a perpendicular coil like this one, the magnetic field are from north to south. During this position, the coil is either moving to the right or to the left based on the rotation of the motor. So the rotation is exactly parallel to the direction of the magnets, which is why the induced EMF should be zero under these circumstances, which is why whenever it's flat, the magnetic field is either this way or this way. It's in exactly the same direction where the coil wants to rotate, generating no EMF. EMF is only generated when the coil actually exists in this plane or shifts from that plane to this one, because only then these magnetic field lines are actually being cut like this. The coil rotates like this or passes through them. During rotation, maximum cutting takes place and maximum EMF is achieved, which is why on horizontal situations, the EMF is actually maximum. So coming back to the question, if it is in this position, the starting EMF should have been 0 volt. And if it goes to 180, goes here and this goes here, then there should be, again, the vertical position requires is coming back to 0 volt. So B says starts with a non-zero value, ends at a non-zero value. This is completely wrong. Option A will be the right answer based on orientation and previous knowledge. 33. 3 pieces of magnet material listed. Which pieces equipment? Temporary magnets. Correlative transformer, yes. Needle compass, no. Iron filings, yes. Because iron is not magnetic itself. It's not a magnet itself, but it can respond to an external magnetic field. But in a compass, in a needle, the needle is a permanent magnet. Only then it can respond to other magnetic fields around it. So in this situation, temporary magnets will be part C. Let's move on to the next question. 34 students, speed of the rotation. This is again a question repeated already in the past. Strength of magnetic field, yes, it increases the turning effect. Current increases the magnetic field, increasing the turning effect. Number of turns of the coil, yes, more number of coils, stronger magnetic field. Interaction, which means if you want to increase the speed or affect the change, they are all 3 students, all 3 pointers. 35 is about a transformer. Just by visual inspection, I can see that the number of turns in the primary coil are less, number of secondary turns are high. This will be a step-up transformer. Even if the information is not required in the question, it's my job to access the right part of information from my brain. There are more number of turns, yes, I've seen that. Which statement is correct? There's already current in the primary coil, true. Direct current, no. The transformer cannot change the type of current you give it. So for example, if you're giving AC, it's going to give out AC. And transformer does not work on a DC input because we're relying on changing current. The changing current, sometimes positive, sometimes negative, causes a changing magnetic field. That changing magnetic field, when reaching the secondary coil, actually causes induced EMF, producing the output voltage, like this one. There is a large current in the secondary coil. No, because I can see that if the number of turns are higher, the voltage is higher. If the voltage is higher, the current is low because the power has to stay constant. The input power, whatever is being fed from the primary coil, and the output power should remain the same. So on the secondary coil, I am making a compromise on current by gaining in voltage terms. So this is wrong. Part C, magnetic field of the core. Yes, there is. Seems to be the right answer, but let's see. D is an alternating current in the iron core. No, there are no alternating currents in the iron core. There are alternating current in the secondary coil. So this is wrong too. The best answer will be option C in this situation. 36 was interesting. He says that which path does the alpha take, and beta particles are shown. Beta particles have a negative charge on them, and if they are coming to this side, then that means this should be a positive plate, and this should be a negative plate. So most likely the alpha particles, since they are positively charged, they should move wherever they are. They should move to the upward plate, to the negative plate for that matter. So, but it could be then A or B. C would be gamma and D is nothing, according to your syllabus at least. So it could be B or A. Both are partially correct. The first part, they get right, that the alpha particle, being a positive charge, should go upwards, should go to the upper side. But then when you deep dive into the actual concept, you realize that alpha particles are large in size. They're heavy. They respond slower or less to the electric force or electric field. So it should be B. And this is purely due to inertial reasons, that since alpha particle is bigger and heavier than beta, it responds later to the electric force. Although the electric force is existing, it is exerting on that particle, but it's heavy, it takes time due to inertia. Question number 37, very simple. He says the charge on an electron, charge on the nucleus is positive because of protons, and it's negative due to electrons on the outer shell. Question 38 is from radioactivity half-life. It says one half-life is 6,000 years. It takes 6,000 years for 100% atoms to become 50%. It says how much time passes to get to n by 16 or 1 by 16. There are two ways to do this. Since the starting point of the number of atoms is not given, you can simply start with 100% as one number of atoms, 100%, then divide this by 2 to get 1 by 2, then divide this number by 2 again to get 1 by 4. When do I stop counting? When we get the stopping criteria done. When what he's asking is going to be 1 over 8, then again divide by 2 gets 1 over 16. If you're not comfortable with this, you could have done the reference method in terms of n. So the total number could be 1,000, 10,000, 100,000, we don't know. But in the next half-life, they will be halved. In the next, they will be quarter. In the next, they will be n by 8. In the final, they will be n by 16. Since I'm getting the same numbers again from the question, I will stop the question. Now, it's my time to count the number of arrows, because 6,000 is one arrow. It's time for one halving process to go through. So it's 1, 2, 3, 4. 4 half-lives have passed for an object to go from 100% of its activity, number of atoms, or its quantity, to 16th of its original value. It will take 4 half-lives, which one half-life is 6,000. So 4 multiplied by 6,000 gives me 24,000 is going to be the answer. 39 is also written in your syllabus, and it's a common question. You can notice it over here. It takes 500 seconds to get to Earth. So it's going to be option D. Question 40 is again from memory. Where is the solar system? Where in the solar system is the asteroid belt? It's between Mars and Jupiter, between rocky planets and gas giants. So it should be option C. We can't really help you with MCQ number 40 because it's all about memory. 39 and 40 are about memory. But anyways, I hope you've learned something. I'll see you in the next video.